So in the previous video, we talked about the key idea behind transfer learning that allows us to leverage general large data sets. In this video, we are now going to discuss the different types of transfer learning. So first, we are going to take a look at transfer learning variants from a dataset perspective. So one variant of transfer learning is that we train our model on a large general data set, and then we fine-tune it on a smaller data set, as we discussed in the previous video. Another way we can leverage large data sets is that we can train the model on a combined data set. So we can combine this large data set with a smaller target data set. And a third way we can leverage large data sets is a variant of transfer learning where we train the model on the large general data set, and then we train it further on a combined data set that includes the large general data set and our smaller target data set. So now let's take a look at transfer learning variants from a model perspective. So for the upcoming slides, we assume that we already pre-trained our model on the large general data set, and we are going to focus in on the fine-tuning aspects. So let's take a look at the first variant of transfer learning where we fine-tune only the last layer. So like before, the first step is to train the whole model on the large general data set. So after training the model on the large general data set, we freeze all the model weights. And then in step 3, we replace the last layer, the output layer of the neural network. The reason why we do that is that the last layer of the neural network is usually very dataset specific. First in terms of the number of classes, but then also in terms of the knowledge that it learns. Whereas the other layers in the network are more like general feature extraction layers. So now after we replace the output layer, what we do is now we train the neural network on the new target dataset. Notice that the backbone of the network remains frozen, so we only update the new output layer. And that would be one variant of how we can use transfer learning. A second variant is to train multiple output layers. So again, in step 1, we train the whole model on the large data set. We freeze the output layers, and then we replace again the last layer, but we now update all the different fully connected layers in the network. So in contrast to variant 1, we are updating multiple output layers here. In practice, usually this tends to perform slightly better than the previous variant because the fully connected layers are usually very dataset specific, whereas the convolution layers, the backbone, is usually the general feature extraction part. So now let's talk about the third variant where we fine-tune the whole model. So again, just like in variant 1 and variant 2, we first train the whole model on the whole large general dataset. Then again, we replace the last output layer, but now instead of only updating the last layer, we train this model on the large data set and update all the layers. This variant is actually a little bit more expensive than the previous two variants because we have to update all the weights. However, depending on the task, the classification task, this might result in a better predictive accuracy. Now we covered so many different paradigms of transfer learning, and you might be wondering which one you should be using. Yeah, this is actually a tricky question, and which paradigm to use actually depends on the situation. So it depends on the problem at hand, and you can treat it essentially like a hyperparameter where you should try out different variants and see which one performs best in your situation. Okay, so now that we talked about the different types of transfer learning, let's try them out in practice.